Oh, here we go. Nice domain and interval notation. So I guess maybe it's more like this one that we're looking at. And just like we've seen before with these types, with this square root business, the only thing we need to understand is that the inside of that square root, the 9x minus 7, it could equal 0, that'd be fine, but it also has to be greater than 0, because inside a root, square root like this, you can't have negatives. There's no number multiplied by itself that gives you a negative. So we're just going to solve this like we would regular inequality, right? So we're going to say plus 7 from both sides. Zero that out, drop our 9x. Still greater than or equal to. Now 0 plus 7 is 7. And last thing here is divide both sides by 9. Let's make this x still greater than or equal to 7/9. And just like we've seen before, if this 9 were a negative, then I would have had to divide both sides by negatives, which would have flipped that inequality. But we didn't need to. And so this is the inequality for our domain. But it did say, well, we want the interval notation. So I'm going to use a graph for this one. Let's put 7/9 here. Okay. And this one, there'd be a closed circle at 7/9. That one's eating the x, which means that the line should go to the right. And again, for me, I like the graph just because I can visually see what the interval should look, or where the interval is. So starting at 7/9 in this interval, it's going to be included. So I got a square brackets there, but it's going to go all the way to infinity. And then I close that with regular parentheses because infinity is never actually included. It's a value we can't actually calculate. So this is the interval right here at the bottom.